So today we're going to be doing lesson 7-1, which talks about parallel lines and angle relationships. So make sure you have your Springboard book open. We are on page 73, something to write with. And it also will probably be very helpful if you have your Activity 7 vocab sheet handy, because you are going to be getting tons of new vocab today. So let's go ahead and get started. So today we're going to be making conjectures about angles that are formed by a pair of parallel lines and a transversal. So that kind of leads us to our first new vocab word here, which is parallel. So two lines are parallel if they are coplanar and do not intersect. So let's draw some lines here. So coplanar just meaning they're in the same plane. And parallel means that they never cross each other. So two lines may be like this. So no matter how far they go in both directions, they're always going to run kind of side by side. They're never ever going to cross each other. Okay, so a few ways that we denote that something is parallel is we kind of mark the lines using little arrows like this. So they might just use one arrow, they might use two arrows, kind of just depends on how they mark the graph. But anytime you see lines with these markings, you can assume that they're parallel lines. Another way that we kind of notate that something is parallel, so say I name these lines M and N, I could say that M is parallel to N. So kind of two straight lines side by side. That's a little symbol that means parallel. Okay? So let's jump ahead to our next vocab, which is a transversal. So a transversal is a line that intersects two or more coplanar lines in different points. So if I just draw a picture really quick. Say we had two lines like this. Okay. What a transversal does is it runs through those points and cuts through them at different points. So like here and here. Okay. Now, when we start to have a transversal that cuts through parallel lines, we get these special type of angles. So we get special kind of relationships between our angles here. So let me kind of direct you to this picture. So when we have parallel lines that are cut by a transversal, so here's my transversal. Okay, we get 8 kind of unique angles here. We have some angles that we would call exterior angles and some that are interior angles. So exterior angles are formed by being outside of your parallel lines. Okay, so see how we have your parallel lines, those are outside or exterior angles. Okay, our interior angles mean that those are angles that are inside or between your two parallel lines. So we would call those the interior angles, okay, or inside angles. So when we are looking at these 8 angles that are formed from parallel lines cut by a transversal, okay, we get these special kind of angles. So one of those is corresponding angles. So here I have 2 parallel lines, and I'm going to cut them with a transversal. So the corresponding angles are angles that are on the same side of the transversal. One angle is outside and one angle is inside. So we have one angle that's exterior and one that's interior. So let me kind of just mark where those would be on here. So corresponding angles could be like an angle right here, and its corresponding angle would be that one below. So you see you have one interior and one exterior. Okay. Another set of corresponding angles could be this angle here with this angle here. So one's exterior, one's interior. So if you kind of remember, corresponding means they kind of are matching in a way. They're kind of like matching angles. They just happen to be in different places. Okay, but so if I look at these 2 orange lines, they're both angles that are below the parallel line. Okay. Same thing with the yellow ones. These are both angles that are above the parallel lines. So corresponding, they're kind of matching angles. They're just in different spots, but they're always going to be on the same side of the transversal, meaning both on the left side or both on the right side. Okay. So the other angles we have 2 pairs of same side interior angles. So if you remember really quick, remember the interior angles are the angles that are in here between your parallel lines. And if they're same side, that means they're on the same side of the transversal. Okay. So an example of same side interior angles would be like this angle with this angle. They're on the same side of the transversal, both interior angles. Another example would be another pink one. If we had this angle and this angle, those are both same side interior angles. So we have two pairs of those angles. Again, they're the same side of the transversal, both interior angles. Okay. Lastly, we have alternate interior angles. I'm going to move that to over there for a second because I'm going to come back to those. Okay. Alternate interior angles mean that they are interior, so they're going to be inside between your parallel lines. And then they're alternating, meaning they're going to be on opposite sides of the transversal. So here is an example of some alternate interior angles. So like this angle here and this angle. Okay, similarly, we can look at the other side too. Those angles would also be same side interior. Now your book doesn't talk about this too much yet. Okay, but we can also have same side exterior angles and alternating exterior angles. So that's why I kind of pulled up some more lines here. I'm just going to show you really quick while we're here talking about our angles. Okay, so if something is a same side exterior angle, they would be somewhere like here. So on the same side of the transversal, but exterior. So there and there. Okay. Similarly, if we had these angles are also same side exterior angles. So on the same side of transversal, both exterior, meaning outside the parallel lines. And then also if we have alternate exterior angles, okay, meaning they're on alternate sides of the transversal, but they're exterior lines. So like there and there. Those would be alternating exterior angles. Same thing if I do these other two exterior angles. So they didn't talk about those quite yet, but I just figured we might as well talk about them while we're here. So again, corresponding angles, they're kind of matching angles on the same side of the transversal. Same side interior, they're on the same side of the transversal inside the parallel lines. Same side exterior, they're just outside the parallel lines. And then alternate interior angles are both inside the parallel lines, so between the two lines, but on alternating or opposite sides. Same thing with exterior, they're just outside the parallel lines. So there are three properties here that we know about these angles. So when you have two angles that are corresponding, so if you have parallel lines, then their corresponding angles are going to be congruent. So if you have parallel lines cut by a transversal, those corresponding angles are going to be the same measure. They're going to be congruent. If we have same side interior angles, okay, so same side interior angles formed by a transversal cut through parallel lines, then we know that those angles are going to be supplementary. And lastly, if you have alternate interior angles, so angles that are parallel cut by a transversal, their alternate interior angles are going to be congruent as well. Okay, so if I just draw, I'm going to draw one more set of lines here. So parallel lines cut by a transversal. So let me cut it. So say I number these angles. We have 8 angles that are formed. 1, 2, 3, 4, 5, 6, 7, and 8. So if we have corresponding angles, so say like angles 1 and angle 5, Okay, those are same side, and they're corresponding, meaning they're both kind of in matching spots. So in this case, I could say that angle 1 is congruent to angle 5. And again, any set of corresponding angles, like angle 3 and angle 7, angle 2 and 6, 4 and 8, those are all corresponding angles. So those would all be congruent angles. I'm just giving you one example. Another one, so say I pick a pair of same side interior angles. So maybe I'll pick like angle 4 and angle 6. Those are same side of the transversal, and interior inside the parallel lines. Those are going to be supplementary. So if I take angle 4 and add it to angle 6, we know that those are going to be 180 degrees. And again, there's more. Angles 5 and angle 3 are also going to be supplementary. Okay, and then if they are alternate and interior angles, so maybe I'll pick angle 3 and angle 6. Okay, alternate, meaning opposite sides of the transversal, and they're both interior angles. Those are going to be congruent. So I know angle 3 is congruent to angle 6. Okay, and just so we know, these properties are also true for the exterior angles. So same side exterior angles are supplementary, and alternating exterior angles are congruent. Okay. So those are just a couple examples. Again, that's not all the angle pairs. I was just kind of showing you a couple of them. So let's kind of jump ahead again. So on this page here with number 6, they're just showing you now that they're going to start calling these the corresponding angles postulate. And just so you know, they list all the postulates in the back of your book. So you don't have to, go back and find these in the sections. You can always check the back of the book. They're listed there all together on page 643. And then we also have they're going to start calling this the alternate interior angles theorem and the same side interior angles theorem. And again, those theorems just say if they're alternate interior angles, they're congruent. They're same side interior angles, they're supplementary. That's what those theorems are telling us. Okay, so we're going to practice some problems here in the check your understanding, and then we're going to be done. Okay, so it says in 8, explain how you know that angle 4 and angle 6 are same side interior angles. So if we look at here, they tell us that angle L is parallel to, line L is parallel to M. Okay, and they're cut by a transversal. So that tells me that we have those 8 unique angles that are made when we have parallel lines cut by a transversal. So how do we know if angles 4 and angle 6 are same side interior angles? Well, if we have our transversal here, that's not very straight. Maybe I'll just use a line. There's my transversal. So as we can see, those are on the same side. They're both on the left of the transversal. And remember, if they're interior, that means they're on the inside or between, okay, your 2 parallel lines, which they are. Okay, so they're same side interior angles. Okay, what does number 9 say? Angles 2 and 3 are they corresponding angles? Explain how you know. So let's look at those angles that they tell us here. Angles 2 and 3. So here's 2. Maybe I should use a different color. Angles 2 and angle 3. Are those corresponding angles? What do you think? Okay, well, no, those are not corresponding angles. Like angle 2 and angle 5 would be corresponding angles because they're kind of the same angle, just in the different placements. But angle 2 and angle 3, those are just adjacent angles. Okay, so those are not anything special. Those are not corresponding angles. Okay, let's look at number 10. If the measure of angle 5 is 65 degrees, okay, then what is the measure of angle 4? So this one here. So if angle 5 is 65, what is angle 4? So think about what kind of relationship does angle 4 and angle 5 have together. So what do you guys think that angle is going to be? Okay. Well, if we look at these angles, 4 and 5, Those are alternate interior angles. So what do we know about alternate interior angles? Is those angles are congruent. So if angle 5 is 65, then so is angle 4. Okay? All right, last one, number 11, let's look at. They are telling us that angle BCD and angle CGE are corresponding angles. So they're telling us that. That's a given. Okay? So they're telling you that angle BCD is 3x plus 6, and angle CGE is x plus 24. So we need to set up an equation to solve for x. So how would we do that? If we know their corresponding angles, what do we know about those angles? Okay, well, hopefully you remember that corresponding angles are congruent. So if they're congruent, then I can set up my equation like this. I can take 3x plus 6 and equal it to x plus 24. So go ahead now and solve that problem for x. Let me know what you get. Okay, so when I solved for x, I got that x was 9. And here's my work for that. So I moved my x's on one side, my constants on the other, and that's how I got x is 9. So now let's answer question B. If x is 9, what is the measure then of angle BCD? So what is the measure of this angle? Well, I got that it was 33 degrees. So what we just did is we take our value that we just got for x and substitute it in. So 3 times 9 is 27, plus 6 gives me 33 degrees. Okay? So the big takeaway today is from that second page of our notes that we did. So this page here. So just knowing how we can relate all those angles together. Okay, so knowing where corresponding angles are same side interior and exterior angles, and knowing how to pick out those alternate interior or even those alternate exterior angles. Okay, and knowing those relationships between them. Corresponding and alternating ones are going to be congruent. Interior, same side, are going to be supplementary. Okay. So tomorrow we're going to do a little bit more with lines that are parallel. So I'll see you in the next video.